Hello, I'm Pete Bellotta. Today, we're going to look at a truly unique power tool. Not only because it doesn't require blades, bits, or abrasives to perform its intended function, but also because it allows you to transform a rough piece of stock into a finished object without the aid of any other power tools. All that's required is a pair of steady hands, a few hand tools, and a vivid imagination. After all, isn't that the true essence of woodworking? Join me now as we look at the lathe. A lathe is designed simply to rotate a piece of stock and does not perform any type of cutting function. Because of this, a lathe is technically known as a wood-turning machine rather than a woodworking machine. Like most workshop power tools, lathes come in large stationary models as well as benchtop units commonly called mini lathes. All lathes consist of four primary components including the headstock, tailstock, bed, and tool rest. The headstock contains the lathe's drive mechanism, which on this model is made up of two variable width pulleys, a spindle, and an electric motor. Power is transferred via a belt drive with a pair of continuously variable pulleys providing the machine's total speed range, which typically falls between 350 and 3,000 RPM. To provide variable speeds on less expensive lathes, a series of stepped pulleys is used. The spindle is threaded on the outside to accept various accessories, such as this bowl-turning faceplate. On some models, the spindle can be locked by engaging a spring-loaded lock pin. Locking the spindle makes it easier to remove attached accessories. Other items, like this tapered drive center, fit into the spindle's hollow shaft. Supporting the opposite end of the workpiece is the tailstock, which has a large hand wheel to control the fore and aft movement of its spindle. To dislodge the drive center from the headstock, a long rod is normally provided with the machine. Connecting the head and tailstocks is the lathe bed. Typically made of cast iron, the bed also serves as a rail for the adjustable tool rest, which, as its name implies, supports the blade of a turning tool. Turning tools are essentially a wood turner's chisels. Unlike a chisel, however, a turning tool has a longer blade fitted with an even longer handle. In addition to turning tools, inside and outside calipers are essential for measuring workpiece diameters. The most common turning tools include the roughing gouge, which is used to remove large amounts of material quickly. As the name indicates, the roughing gouge leaves behind a rugged surface. The skew is designed to smooth the stock by acting like a hand plane. As you can see, there's a noticeable difference between the half that's been turned with the skew compared to the other half of the stock. The same finished surface can be achieved by using a square end chisel, which is moved across the stock laterally in small increments and then moved across the tool rest gradually to remove the ridges. A parting tool is designed primarily for marking out the layout lines from a template. To establish the finished diameter of a workpiece, calipers are used to take periodic measurements in the appropriate locations. Once the layout lines have been cut to the required diameter, the profile is cut using a detail gouge and then sculpted with the appropriately shaped scrapers. On this piece, the operator is using a domed scraper followed by a square scraper to achieve the finished design. While a lathe can be used for a variety of wood turning tasks, spindle turning, also referred to as turning between centers, is the most common. In this section, we'll look at how to prepare and mount the material. To begin, locate the center on each end of the stock. This can be easily accomplished by drawing diagonal lines from corner to corner. Since we're working with square stock, the next step is to remove the hard edges, which is done by first laying out an octagon with a compass. To do this, place the point on a corner and the pencil in the center. Now, swing the compass in an arc and make a mark to the left and right. Next, use the square to connect the marks around the perimeter of the workpiece and then repeat the process on the opposite end. Using a fine-toothed trim saw, cut shallow kerfs along the intersecting lines of approximately 1/4 inch deep. The kerfs allow the jaws of the live center to penetrate the stock easily for greater holding power. Now, Draw lines along the length of the workpiece between the pencil marks. The lines will serve as guides during edge removal. Using a jack plane, ease the edges of each corner down to the pencil marks. Finally, align the live center with the center point in the stock and the spurs with the kerfs. Use a wooden mallet to set it into place. Before mounting the stock, make sure the lathe is operating at the lowest speed. With the speed properly adjusted, slide the tool rest out of the way and then retract the tailstock sufficiently to make room for the workpiece. Now, slide the live center into the spindle shaft. While supporting the right end of the workpiece with your left hand, use your other hand to bring the tailstock toward the work and lock it to the bed. Align the tail center with the center point in the workpiece and crank the tailstock shaft in until fully seated. At this point, lock the shaft into place and recheck the tailstock lock. Adjust the tool rest to within 1/4 inch of the work, making sure it's slightly below the center line of the spindle shafts. Now, rotate the workpiece by hand to ensure adequate clearance. After running the lathe for a few minutes, loosen the tailstock shaft and crank it in at an extra turn to ensure the workpiece is secure. If you notice any excessive vibration with the lathe running under no load, check for the following conditions: lathe speed too high, incorrect workpiece alignment, and/or an unbalanced workpiece. Now that you know how to mount the workpiece and are familiar with common wood turning tools, we're going to look at the basics in tool control and cutting techniques. Before we do, however, take note of these important safety guidelines. Never wear jewelry or loose clothing when operating a lathe, and make sure long hair is tied back. In addition, always wear a clean, full face shield to protect yourself from flying chips and debris. Because body position is critical to good tool control, set the lathe at a comfortable working height. While this will vary for each individual, as a general rule, the center line of the workpiece should be in the same plane as your elbow. When spindle turning, face the lathe with your body positioned about 45 degrees to the machine and your feet spread a little wider than your shoulders. Never stand too close to the machine, since you'll be forced to lean into the work. This can lead to a loss of tool control and potential injury. Grip the turning tool firmly with one hand and tuck your elbow into your side. Use your other hand to manipulate the blade as you slide it along the tool rest. When making rough cuts, use an overhand grip to control the blade. For precision cutting, use an underhand grip with your thumb on top of the blade. Position your index finger against the lip of the tool rest and use it to guide the tool along the workpiece. Your hand allows you to control the depth of cut by positioning the tool correctly and then pinching the tool between your thumb and index finger. As you can see, good tool control depends on how well your body is positioned relative to the lathe. Now, let's look at the steps involved in turning a piece of round stock into a tapered staircase baluster. To begin, mount the stock to the lathe using the technique shown earlier. Next, place the design template against the stock and then transfer the layout lines from the template to the material. With the stock marked off, install the tool rest and set it to within 1/4 inch of the stock, slightly below the center line. Be sure to rotate the stock to ensure adequate clearance. Now, using the tool rest for support, align the pencil with each of the marks and rotate the stock to extend the pencil marks around the circumference. Proceed by turning the lathe on and setting the turning speed to approximately 50%. To avoid damaging a lathe equipped with continuously variable pulleys, never change speeds unless the machine is running. To establish the baluster taper, measure the width of the template from the center line to the edge at each of the previously marked points. Multiply each measurement by 2 and mark the template accordingly. Now, set the calipers to the first dimension. Begin cutting on the layout lines with the parting tool and check the diameter of the workpiece regularly with the calipers. Now, repeat the process for the remaining layout lines, making sure to reset the calipers as needed for each successive cut. Once the depth cuts have been completed, begin turning the profile using the tool best suited for the application, which in this case is a flat scraper. Make sure to keep your elbow tucked tight to your body and use an underhand grip with your thumb on top of the tool for optimum control. While cutting the pattern, it's recommended to focus on the back side of the stock to observe the developing profile. After turning the length along the tool rest, reposition the rest to the next unfinished area. With the profile created, remove the tool rest and then turn the lathe on and increase RPM to 75%. Now, sand the piece with a fine grit paper for an ultra smooth finish. To prevent the paper from tearing, the piece should be folded in half. Be sure to always wear a dust mask when sanding on a lathe. After sanding, use the parting tool to establish the ends of the baluster. Warning: to prevent personal injury and/or property damage, be sure not to cut through the stock completely with the parting tool. To complete the baluster, cut the ends off at the previously made parting lines. Although a lathe doesn't require regular maintenance and adjustments like other workshop tools, using it effectively takes considerable practice. Hopefully, you now have the confidence to get started. Now, let's review the key points of the program. Like most workshop power tools, lathes come in large stationary models, as well as benchtop units, commonly called mini lathes. All lathes consist of 4 primary components, including the headstock, tailstock, bed, and tool rest. Turning tools are essentially a wood turner's chisels. Unlike a chisel, however, a turning tool has a longer blade fitted with an even longer handle. In addition to turning tools, inside and outside calipers are essential for measuring workpiece diameters. If you notice any excessive vibration with the lathe running under no load, check for the following conditions: lathe speed too high, incorrect workpiece alignment, and/or an unbalanced workpiece. Never wear jewelry or loose clothing when operating a lathe, and make sure long hair is tied back. In addition, always wear a clean, full face shield to protect yourself from flying chips and debris.